Visit Chandra's beautiful universe, G292.0 plus 1.8. A young pulsar is blazing through the Milky Way at a speed of over 1 million miles per hour. This stellar speedster, witnessed by NASA's Chandra X-ray Observatory, is one of the fastest objects of its kind ever seen. This result teaches astronomers more about how some of the bigger stars end their lives. Pulsars are rapidly spinning neutron stars that are formed when some massive stars run out of fuel, collapse, and explode. This pulsar is racing through the remains of the supernova explosion that created it, called G292.0 plus 1.8, located about 20,000 light-years from Earth. To detect the motion of the pulsar in X-rays, astronomers needed the sharp vision that only Chandra has. Because the pulsar is so distant, it took the equivalent of resolving the width of a quarter about 15 miles away to see this motion. To make this discovery, the researchers compared Chandra images of G292.0 plus 1.8 taken in 2006 and 2016. From the change in position of the pulsar over the 10-year span, they calculated it is moving at least 1.4 million miles per hour from the center of the supernova remnant to the lower left. This speed is about 30% higher than a previous estimate of the pulsar's speed that was based on an indirect method, by measuring how far the pulsar is from the center of the explosion. The newly determined speed of the pulsar indicates that G292.0 plus 1.8 and its pulsar may be significantly younger than astronomers previously thought. The astronomers estimate that G292.0 plus 1.8 would have exploded about 2,000 years ago as seen from Earth, rather than 3,000 years ago as previously calculated. Several civilizations around the globe were recording supernova explosions at that time, opening up the possibility that G292.0 plus 1.8 was directly observed. However, this event would have only been visible from the southern hemisphere, and so far there have been no confirmed supernova sightings from that half of the globe in previous millennia. In addition to learning more about the age of G292.0 plus 1.8, the research team also examined how the supernova gave the pulsar its powerful kick. This latest result supports the explanation that asymmetry in the explosion debris gave the pulsar its kick, and this lopsided explosion imparted the pulsar with about 200 million times more energy than Earth's motion around the Sun. The researchers were able to make this remarkable measurement because they combined Chandra's high-resolution images with a careful technique of checking the coordinates of the pulsar and other X-ray sources by using precise positions from the Gaia satellite. It's yet another example of how using data from more than one telescope makes for more powerful science.